Hello, Wolves. This is Pre-Algebra Chapter 3.4, Solving Inequalities Using Addition or Subtraction. An inequality is any statement formed by placing an inequality symbol between two expressions. Examples of inequality symbols are greater than, less than, greater than or equal to, or less than or equal to. For example, y plus 5 is less than or equal to negative 6 is an inequality statement. We're going to be evaluating inequality statements, looking for the solution. The solution of an inequality with a variable is the set of all numbers that produce true statements when they're substituted for the variable. We can demonstrate inequality solutions using number lines or graphs. For example, if we know that our inequality is x is less than 3, we could draw a number line to demonstrate that x is equal to any number less than 3. 3 is not included in this set because x is less than 3. So we would represent that by drawing an open circle over 3 and drawing a line to the left. This is how we would graph the inequality x is less than 3 because the solution includes all numbers less than 3. Let's look at another. Y is greater than 2. So y is equal to all numbers larger than 2. We would graph this by drawing an open circle over 2 and drawing an arrow to the right. Because again, recall, if y is greater than 2, it cannot be equal to 2. It can be equal to 2.0000001, but it cannot be equal to 2 itself. So we have an open circle to demonstrate that 2 is not included. Another example of an inequality could be z is less than or equal to 4. So the solutions for z would be all numbers less than or equal to 4. We graph this by drawing a closed circle over 4 to show that 4 is included in our set. Our arrow would then go to the left to show that any number less than 4 is also included. Finally, let's draw an example where our variable is greater than or equal to a digit. N is greater than or equal to 2. We'll graph this on the number line by drawing a closed circle at 2 to show that 2 is included in the set, and drawing an arrow to the right to indicate that all numbers to the right or greater than 2 are included in the set that makes n true. Now let's work a sample problem together. Let's write and graph an inequality. The freezing point of water is 0 degrees Celsius. At temperatures at or below the freezing point, water is solid, or ice. Write an inequality that gives the temperatures at which water is solid, and then graph that inequality. So we're going to let T represent the temperature of our water. Water is solid at temperatures less than or equal to 0 degrees C. So we'll write our inequality as T is less than or equal to 0. We're going to graph our inequality by drawing a closed circle at 0, because 0 is included in our set that makes our statement true, and we'll draw an arrow to the left. So here are our two solutions. Here is the inequality, and here is the graph of the inequality. Now let's move on to solving inequalities. Solve this inequality. M plus 5 is greater than or equal to 10. So we'll simply solve this using the same techniques that we've used to solve equations. We're going to use the addition and subtraction properties to find or isolate m. So in this case, we'll take m plus 5 minus 5 is greater than or equal to 10 minus 5. M is greater than or equal to 5. And there's our solution. Now we can graph our solution to check our work. I've drawn a graph here so that we can graph m being equal to or greater than 5. To check our work, we'll simply choose any number that falls in our set and replace it in our original inequality. So for example, let's choose the number 7. Now we'll substitute 7 into our original inequality. M would be 7 plus 5 is greater than or equal to 10. Well, when we simplify this, we get an answer of 12 being greater than or equal to 10. 12 is definitely greater than 10, so it works. We can also choose a number below to see if we've done our work correctly. So now let's try a number that doesn't fall in our set and see if it works. Let's try 3. Now let's substitute 3 into our equation. 3 plus 5 is greater than or equal to 10. Well, that gives us an answer of 8 is greater than or equal to 10, which is clearly not true. So the numbers below 5 do not work for our set. Now let's solve an inequality using addition. Negative 10 is greater than x minus 12. So here's our original inequality. We're going to balance this and isolate the x by adding 12 to each side. So negative 10 plus 12 is greater than x minus 12 plus 12. 2 is greater than x. Okay. So our solution is 2 is greater than x, or you could rewrite this if you prefer to have your variable first, as x is less than 2. It truly doesn't matter. Let's check our work by graphing this on a number line. Because x is less than, not less than or equal to, we'll use an open circle at 2. And we'll draw our arrow to the left to indicate that all values left or less than 2 are the values for x. Now let's substitute and see if this works correctly. Let's try negative 1. Negative 10 is greater than negative 1 minus 12. That will give us an answer of negative 10 is greater than negative 13. That is true, so this value for x does work. Let's try a number not in our set to see if that works. Let's use a value of 5 for x. Negative 10 is greater than 5 minus 12. This will give us an answer of negative 10 is greater than negative 7. That is not true. So these numbers do not fit in our set. We've done our work correctly by drawing an open circle at 2 and indicating that all numbers to the left or below 2 on the number line are included in our set. Try these 4 practice problems on your own. Solve the inequality, then graph and check your solution. After you complete these 4 problems, we'll finish with one final word problem together. Let's write and solve an inequality using a word problem. You're competing in a triathlon, a sports competition with 3 events: swimming, biking, and running. Last year, you finished the triathlon in 85 minutes. This table shows your times for each event. You swam in 17 minutes, biked in 45, and we don't yet know your time for running. What possible times can you post in the running event and still beat last year's finishing time? So if you want to beat your 85 minutes, how quickly do you need to run? All right, we'll begin by writing this in a word sentence so that we can understand what we need to do with our variables. First, we need to add our swim time, plus our bike time, plus our run time, to equal 85 minutes, our total time. Let's substitute in what we know. Last year, you swam in 17 minutes, you biked in 45 minutes, and you don't know how quickly you ran. Let's say that's the variable t, for a finishing time of 85 minutes. The question is, how quickly will you need to run to beat last year's time? If that's the case, I want to replace the equal sign in this equation, right? I don't want a time that's equal to 85. I want a time that's less than 85. So let's just change that sign to less than. Now we simplify and we solve. 17 plus 45 equals 62. So 62 plus t will be less than 85. We subtract 63 from each side, giving us 23. So if you want to beat last year's time, you need to run in 23 minutes or less. I hope you've been training hard to do that. And when I see you tomorrow, we'll work on some more exercises where we solve inequalities. See you then.